Welcome back to the second part of the Multicam CNC router pinion shaft repair. Today we'll be remaking the shaft. We're going to change the keyways. Rather than using the roll pin, we'll go with a straight key and a woodruff key in the knurled portion. The finished part will be 3 inches long, so I started with a slightly longer piece of 1/2 inch 17-4 stainless steel and installed it in a 1/2 inch collet on the manual lathe. And like most lathe operations, we'll start out by facing the stock in preparation to center drill it. This part will be held between centers for the grinding operation, so we'll need to drill a 60-degree center in each end. And so here I am just putting the first end into the part. Next, flip the part around and leave some material sticking out. This end will be coated with a thin coating of dicum, and this will allow us to scribe the final length so that we can face off this other end and get a good length. Over on the surface plate, I've set the height gauge to 3 inches, and I'm scribing a line. I'm using a V-block to hold the part straight. Back over on the lathe, I'm going to remove the excess material, face it off to the line, and then I'll center drill it. Extend the stock about 1.5 inches in preparation for knurling. Even though the knurled portion is only about 5/8 of an inch, we're going to knurl the first, 1.25 inches roughly. We'll over knurl it, and then we'll machine off the excess knurl. By over knurling, this ensures that we have a clean knurled area where the knurls will be well formed, nice and sharp and clean. And by knurling a larger area, we can get the knurl adjusted, and we can make sure that everything is absolutely spot on perfect. The knurling tool doesn't actually cut the knurls, but rather it forms them through plastic deformation. The pressure between the rolls causes the ductile material to change shape, forming the knurled shape, or in this case, the straight knurls. Because the extreme pressures exerted upon the material during the knurling process, an oil is used. And here, after cleaning off the oil, we get our first glimpse at the finished knurls, nice and sharp. Next, I'm going to use a straight grooving tool to cut the bearing shoulder. This does 2 things for me in the turning process. One, it provides a nice flat bearing surface, but 2, it'll provide me with a reference so when I'm machining this end, I will know where to stop. The grooving tool is like a cutoff tool or a parting tool. It just goes straight in and cuts a groove. Following that, we'll come and reduce this diameter down to 7/16. The bar is then flipped around, and the collet is changed out for a 7/16 collet. All of these collets are 5C style, and they come in a variety of sizes, typically in 1/16 or 1/32 increments. Here we're going to hold the part up against the shoulder and support it with a tailstock for the turning of the main body. I started roughing down the body and then decided that I should probably cut in my shoulder, and so I cut in the shoulder and then finished off the main roughing operation. As I get closer to final dimension, I switch from calipers to a micrometer for better accuracy, and I finished the part I think 5 thousandths oversized. I wanted enough that after heat treat it could be ground. So here I am just finishing off the final end. Being oversized, it was a little bit snug in the collet, but it pulled out okay. And after giving it a quick inspection, I took it over to the surface grinder and I cut that 5 thousandths down to 2.5 thousandths in preparation for cutting the keyway. Cutting the keyway on this little shaft required a fixture, and so here's a quick design that will allow me to hold the part. The part will be machined out of just a piece of scrap, so here we are just facing off the part, followed by an adaptive clear. This is a roughing operation. Once the part is roughed down to the final dimension, it's then contoured, drilled, and then finally, after drilling, it'll be tapped and chamfered. It really doesn't take that long, but having a fixture like this makes it really easy to cut in these features on this little teeny shaft. The 1-inch straight key slot was cut with a 303 cutter, and the woodruff key was cut with a 404. If you recall, a 303 is 3/32 by 3/8, and the 404 is 1/8 by 1/2. Here's the finished shaft with the keys cut into it, ready to be heat treated. Fixture worked out great, and I'm very happy with it. This shaft was made from 17-4 pH stainless steel, and it heat treats at 900 degrees Fahrenheit or 480 degrees Celsius for 1 hour to what's called H900, which is its hardest state. It is then air-cooled to room temperature. When it's finished, it should have an oxide layer that's even and brown like this. Type 630 stainless steel, more commonly known as 17-4 pH, or simply 17-4, is a grade of martinistic precipitation hardened stainless steel. It contains approximately 15 to 17.5% chromium and 3 to 5% nickel, as well as 3 to 5% copper. The name comes from the chemical makeup, which is approximately 17% chromium and 4% nickel, thus 17-4 pH stainless steel. Here I'm just finishing up the final grind of the part to its final dimension in preparation for reinstallation in the machine. Here you can see it turned out absolutely beautiful, wonderful. I used the arbor press to press the shaft, knurled portion, and the woodruff key carefully into the pulley. Turned out great. I ordered an exact replacement of the original pinion and then decided to modify it with a straight key and 2 set screws 90 degrees apart. it started by needing to broach the 3/32 key into the pinion. So here I am at the arbor press, getting it prepped in the bushing, and I'm going to carefully get it started. And broaching actually requires you to go pass through the part twice. So on the second pass I would use a shim. I didn't record everything on the broaching process, but here it gives you an idea of kind of what it looks like through the process. The pinion was then drilled with a number 36 drill and tapped for the number 6 32 screw, and it was done above the key and then also turned at 90 degrees. I didn't have the key of the correct thickness on hand, and so I simply took an oversized chunk of key stock and put it on the surface grinder and whipped it down to shape. I'm using the sheet metal to hold it in place. Didn't take very long. Of course, as soon as I had the key done, we promptly reassembled the gearbox and put it back on the machine. And so I took a picture, a couple pictures kind of show you what it looks like in operation, but I didn't get any of the assembly portion. It was, at the end of the day, honestly, I just wanted to get it done and go home. But we did make a test cut. The test cut looks really promising. The hole went in, it looks round, looking good. I think we've solved our problem. Sometimes it's hard to tell in wood because of the fibers, but a 6mm drill fit through the hole. It's definitely a lot better. Thanks for watching. Have a great day.